So looking at this, it has a serial input on the back, right? But so you can send it commands and it will just respond to them. But there's no outline of what these commands actually are or how many there is of it. So I've looked online and looked around. The easiest way and the first way when you're modifying something is to go to the line of least resistance and ask the manufacturer for the things, or look to see what it's been provided by the manufacturer. It hasn't in this case, at least I've not heard back from them. There are other monitors from Panasonic with the full list of serial commands what to send it, but it has this little remote unit on it, right? So that is kind of a remote, but it's not the remote that plugs into this serial port on the back, which is this classic kind of 9-pin D subs at the bottom. No, so that's a classic serial. So then you can control it literally from anything from the computer, you know. So that is just controlling it from, you know, twiddly knobs outside of the thing, right? But I opened it up, and it is actually serial. This is the service manual. Here's the 4, 1, 2, 3, 4. Those are the 4 rotaries, and they have a switch in each one. There's also some LEDs over here. Here's the drivers for the LEDs, actually. So what you've got is 2 parallel to serial converters, and you've got 1 parallel to serial. Oh, sorry, no, I've got that wrong. 2 parallel to serial and 1 serial to parallel, because that driving the LEDs at the end, there's only 4, they're only using half of that one. So that's coming from the operating system, the monitor itself, coming out to the LEDs at the front and saying you turn on, because that switch has been selected to say that, you know, you've turned on the contrast control, and then it will go to that. And you've also got switches on the front panel. These are just 1, 2, 3, 4, 5 switches, and here's your 5 LEDs for those functions as well. So they all get summed together. They go into here. They're all summed together with these as well. It converts them into serial. So that chip goes from parallel to serial. It puts it into this one, and then it converts a load of other of the switches to serial also. The output of that then goes back up to the operating system in the monitor itself as serial. So it comes out as a serial stream of all of the 4 things. So what I'm going to do now is, I've determined which ones these are on each of the ones. They're all the same. Once you've figured out one, that's fine. Well, actually, I was in the process of extending this remote cable and making it longer so I could operate it from a bit more of a distance. That's a very short cable. So, inspired by the light Herdo, he's been working a lot with these monitors, right? So, but I wanted to really control it with the camera. So now I don't have these serial commands as in RS232 serial, but they do exist here already as this, you know, serial stream, all being multiplexed together by these few chips. So now I'm going to get a logic analyzer set up and probe these 3 points as 1, 2, 3 on all of the 4 controls, and some on the switches as well, just to see what they're doing, see them in operation, and then I'll capture the data stream as I'm like turning that one around and switch it on and off. Alright, here's the logic capture set up. I'm clipped onto those ICs there, which is the parallel to serial. I'm going to feed the capture data to this logic analyzer. I'll put a link to that in the description. It's a nice open source project. I don't need to capture all of those channels. I got really carried away. I only need to capture 1 encoder at once, that's all. But it's fine. It's better to have too much data than too little. So yeah, here's the level shifter. It's already at, oh no, I need to shift it to 5, yeah. So it's on 5. Pico can only handle 3.3 and that device is 5, so you need to make sure that's at the same level you're capturing that, otherwise you'll hurt your Pico or break it. So yeah, these are the channels there, and I think I got it mixed up and had them on trying to capture the 24 when I was on 1, or vice versa. I usually do something like that. And yeah, then we'll have a look at the capture in a moment. Yeah, so that's the little device. I've got a few of those, you can chain them together. Let's see, we're looking at the logic capture. There's just sort of increase the amount of samples you can see on the screen at one time with that slider. You can see that's the sort of overall view. It's a bit annoying because it always pops up the dock because it's at the bottom there. I think it's designed for Mac, so it's always in the way of the dock, but there you can see more of the capture at one time and scroll through and then just sort of zoom in on these smaller portions, and then you can increase or decrease the amount of samples you can actually see in the screen. So you can see that they're offset with each other. The blue one is 90 degrees out of phase with the other one, or fairly close to. It's because it's a physical encoder. It's not, it's got some bounce to it and stuff like that. But the system just sees it as one transition that starts 90 degrees before the other transition, and that's how it determines whether it's going up or down, because A will start sooner if it's going up and B will start sooner if it's going down, or vice versa, whatever it's set up in the thing, but one of them always starts before the other one. So that's how it knows whether to increment up or increment down, and that's how these digital encoders work. So that's about it really. You can just look at the calculation between them. Is it's not only the peaks and the troughs, it's like how long it takes for both of them to do a full cycle. That's your one state. So they both go from 0, or one of them goes 0, 0, the other one goes 0, 1, then the other one goes 0, 1, whilst the first one goes 0, 0 again, and then it's both of them to go a full position back to what they started. Then you've got, that's 1 in your finite state machine that's going to do the encoder. That's the serial data stream at the top. And yeah, you can see the switch on there somewhere, but it's not really so important, the hardware switch. So yeah, that's what the logic capture looks like. So I didn't need to capture all the channels, or even slightly the amount. I just need to capture one. I don't know why I set it up for all of them. I think I wanted to see where you could get it, whether you could see in the larger data stream where it was putting them together and which one was which. But I can't do that. I can't see that. And you might be able to see that, but again, there's not really much point to do that. It wouldn't add anything. So you can see the larger view popping up in the bottom there. If you've got other areas in your capture you want to look at, you go to the bottom and you move around there. And that's about it for the capture. So then you determine the level of the state, how long it takes to give the state, and you have like a 20 millisecond average turn rate, basically. You can go to a thing at the top where you can show the measurements of of what you're capturing. You put a little selection in and you can say measure, and then it shows high length for A, high length for B, 0 length for A for B, and then you can determine work out what you need to work out from those. It's not self-calculating, but you can load in protocols for different serial languages and things like that. But I don't really need to do that because it's just raw data anyway. It's not conforming to any protocol. It's just literally raw data bits going up and down. So it wouldn't decode to any protocol anyway, like USB, ASCII, or hexadecimal or MIDI encoding and stuff like this. But this is just raw data, so it's already decoded as it is. So I'm having great success with this little program for reading the MCU flash contents, and yeah, after a couple of little starts they'd left it locked. It was locked, but they'd used the standard ID code, which is all zeros or all Fs depending if it's in the chip manufacturer's program. It was all Fs, and then this one it's all zeros, and it actually reads it for you. So yeah, there is little tools that people have made to like actually break the ID code on this, but happily I didn't have to even think about that because it's reading it now, so that's great. Thanks to the German dudes who made this. Definitely not for a profit use. This is what it's going through. It's going to USB into this, which was a little bit of a mare. I'm trying to install the drivers for. I had to actually edit the driver file, the inf file, actual driver of the thing from the manufacturer. It wouldn't work, so I had to look in the Windows thing, find the specific code of the device that was readable in the Windows, and then edit the inf to actually include my device number, which wasn't on there, and then it worked. So yeah, double bit of hacking to even get the bloody tool working. Did 2 reads, one of the like the standard read, and then one of a little bit longer, so it kept the bootloader as well, or the earlier part of the address range. Alright, we're back with the Panasonic. Oh my god, I've spent ages trying to get the serial commands out of the firmware. Well hard. Anyway, it's, yeah, I haven't managed it yet. I found something that sort of looks like it was totally not having it. But this is the fallback. You get a couple of minutes out of the scope, it's running out of batteries. I've got an Arduino sketch programmed on here. I'm hooked up to these 2 pins. It's sending opposite phase square waves, as you saw in the logic capture. The only thing is, at the moment I have to send it on manually, so then there's like a value assigned to that now because it was in a position. That's interesting. Anyway, so it's under control of those 2 coming from the Arduino over there. So then just gonna send it some command. It's just a MIDI program, just to send it some commands, and then should be, there we go, changing the phase up and down, and then you can see down there that it's that won't be there. Like, you can turn that function off, but it's just so you can see it without going mad at the moment, you know, you're like, is it actually moving it or not? So yeah, you can see that it's going up and down, you know, from a MIDI command straight to the USB at the moment. So yeah, I think I'll leave it as that, because it'll be part of a bigger system accepting USB MIDI from a USB kind of host. So it's pretty good control over it. It's the way that it's mapping it was tricky. I mean, I get all that out with these scripts, but yeah, it's kind of, because you can see it more now with the green on the hand, because that's an encoder. Like, it should be able to accept this now as well as that. It should just be like not really contention, but it's I don't want to try it at the moment. So anyway, let's just turn it off, and then you can still turn it on. It sort of clicks, you know, when you rotate them. So that has a different way of doing passing a command on than the slider does. The MIDI slider is sort of like, I think it's like absolute versus relative. I think this is relative and the MIDI slider is absolute, so you have to kind of translate that a little bit. So I think I might be able to, if I connect the switch, which is that yellow one, it's not connected. I think if I do that through an OR, like a diode OR, so that one connects through a diode and this one connects through. So yeah, I don't know what's going on with that, but yeah, that's why it can't pull it high from the microcontroller point of view, because when it's off, it's grounded. It's really grounded, even though there's a pull up to high it's overriding that. It's really grounded, so I think that's why he's not getting out of that. It's not like a logic thing at that stage. So anyway, it's still a little bit confusing. Let's see if we can probe this menu pin, or one of the menu pins. Yeah, you see that one? That's just pulled up high. And there we go. And if I had 3 hands, I could show you that pulling it low, just off one click, but oh, maybe I could use another finger. There you go. So yeah, that is a more typical, so they will work as normal from a microcontroller point of view, and that's those. Well, they're not multi-positioned, you see. It's kind of in, or it's out, so yeah, I think that's been pulled, definitely pulled low, so I don't know. I mean, even if it comes to it, it's like, yeah, you just push that in and then you've got remote control.